April 13th, 2026, that's the day every major global automaker went dead silent. On that day, Guinness World Records officially certified something insane. Geely's new IHEV hybrid engine hit a mass production thermal efficiency of 48.41%. Let that sink in with real-world numbers. The full-size SUV powered by this engine gets 2.22 liters per 100 kilometers under real-world conditions. One full tank pushes its range past 2,000 kilometers. To put it simply, you can drive from Beijing to Guangzhou, a 2,100 kilometer trip, without stopping for gas once. Now here's the trillion-dollar question. For over a century, top Western engineers swore this level of mass-produced thermal efficiency was physically impossible. So how did a Chinese production vehicle shatter that hard limit? Most people write hybrids off as a temporary band-aid for the electric vehicle era, but here's the truth. The old combustion engine era, which everyone thought was dying, is making a brutal comeback in ways no one saw coming. In this video, I'll break down the 3 counterintuitive mechanical secrets behind this 48.41% breakthrough. I'll explain why century-old giants like Toyota, VW, and BMW all failed this physics test, and I'll show how this shift will rewrite global industry profits for the next decade. When you see these numbers, your first thought is probably predictable. Is this just another car company faking specs for clout? Is the 2.22-liter fuel mileage inflated by a huge battery pack? A lot of people claim crazy thermal efficiency numbers only work in labs, never on real roads. These doubts make total sense. So let's clear the basics first. No fluff. That 48.41% figure, it's tested purely on the engine itself. Battery size and motor power have zero impact on this number. It measures one thing only: how much gasoline chemical energy gets turned into actual wheel power. Let's compare it to the global best in the business. Toyota's latest 5th-gen hybrid engine tops out at 41% efficiency. Volkswagen's newest EA 888 Gen 4 hits 38%. BMW's flagship B58 inline 6 maxes out at 37%. Geely's engine beats Toyota's industry benchmark by a full 7.4 percentage points. Don't sleep on that gap. Over the past 30 years, the entire global auto industry only boosted ICE thermal efficiency by less than 10 points total. On top of that, the 2.22 liters per 100 kilometers rating comes from the official WLTC real-world cycle. It's not some fake steady-speed highway test. This car only has an 18 kilowatt-hour battery, with just 120 kilometers of pure electric range. The remaining 1,880 kilometers of that 2,000 kilometer range runs entirely on gas. Basically, no battery cheating here. This engine truly squeezes every last drop of energy out of gasoline. But if you think this is just Chinese brands obsessively chasing better fuel economy, you're missing the entire point of this new industrial war. So what's actually powering this historic leap? Let's break down the 3 game-changing core technologies. First up, the cylinder tornado combustion system. The biggest enemy of engine efficiency is incomplete fuel combustion. Traditional engines burn fuel in a slow, outward ripple. It's like dropping a stone in water. The ripple spreads out slowly, always leaving unburned fuel at the edges. Geely's engineers flipped this playbook entirely. They added a custom vortex generator at the top of each cylinder. As the piston compresses air, it creates a tornado spinning 3,000 times per second inside the cylinder. Gasoline gets injected, shredded into nano-sized droplets, and mixed perfectly with air. Think of it like this. You have a violent, high-speed storm. Instead of letting chaos happen randomly, you line up every single raindrop in perfect formation. All of them ignite simultaneously in a split microsecond, releasing 100% of their energy. Zero dead zones, zero waste. Second tech, the dual cold and hot circulation system. Traditional engines use one cooling system for the entire block. This creates an impossible trade-off engineers have fought for 100 years. The combustion chamber needs extreme heat for full fuel burn. But cylinder walls and pistons need cool temperatures to cut friction wear. Every Western brand just compromised on both. Geely's fix is brutally simple yet genius. They split cooling into 2 independent systems. A high-temperature loop keeps the combustion chamber above 120 degrees Celsius for maximum burn efficiency. A separate low-temperature loop keeps cylinders and pistons around 80 degrees Celsius to minimize energy loss. Simply put, hot parts stay hot, cold parts stay cold. This single tweak alone boosted thermal efficiency by 3 full points. Third breakthrough, the 11-in-1 integrated drive unit. Traditional hybrid setups are a messy chain of separate parts. Engine, generator, motor, clutch, transmission, all standalone components. Power has to travel through 7 to 8 different parts just to reach the wheels. Every transfer wastes energy. Total transmission loss adds up to over 15%. Geely crammed all 11 discrete components into one backpack-sized unit. All power transfer happens internally, eliminating every middleman loss. Here's an easy analogy. Imagine having a blender, microwave, stove, and dishwasher cluttering your kitchen separately. Now picture a single tiny super device that does all their jobs at once. No extra cords, no extra space, no wasted energy from connecting parts. It's compact, clean, and drastically more efficient. Now everyone asks the same question. Toyota and VW have a century of ICE experience. Why couldn't they build these 3 simple upgrades? They absolutely could build this technology. They had working prototypes in their labs a decade ago, so why never put it into production? This is the ugly core truth no one talks about. The 4% efficiency gap isn't a failure of Western engineering skill. It's a failure of their outdated profit system to support radical self-reinvention. Let's run the numbers. Toyota runs over 50 global ICE production lines. Each line costs over $1 billion to build, with a 20-year depreciation cycle. Switching fully to this new engine design means scrapping all 50 lines overnight. That's a $50 billion write-down instantly. Worse still, hundreds of thousands of legacy ICE patents become worthless. Their entire global supply chain built around old engine parts collapses. Tens of thousands of workers and thousands of suppliers lose their core business. That's why you see a bizarre industry trend over the past 5 years. Every Western giant is quietly slashing ICE R&D. Volkswagen officially killed new combustion engine development in 2023. BMW cut 70% of its ICE engineering team. Toyota talks about sticking with hybrids publicly, but shifted all core R&D to hydrogen. It's not that they can't innovate, they dare not innovate. Major upgrades equal corporate suicide for their legacy business model. Chinese automakers have zero of this baggage. No outdated production lines to protect, no legacy patents to prop up. China built its hybrid engine industry from scratch. That means it can adopt cutting-edge designs, new processes, and modern theories with zero hesitation. More importantly, China holds a massive new industrial advantage Western brands can't match. Every design of Geely's engine was finalized via supercomputer digital simulation. Old-school engineering requires months of molding, building, testing, and revising for one small tweak. Today's AI and digital twin tech runs 1,000 different design simulations in a single day. It instantly picks the most optimal solution. This isn't a battle of mechanical talent. It's a generational war between 2 industrial systems. Western giants still rely on century-old trial and error R&D. Chinese manufacturers use 21st century digital-driven development. It's like comparing Abacus math to supercomputer calculations. That's the real reason China went from catching up to leading in just 5 years. Now let's break down what this actually means for you and the global market. First, the technical premium of Western gas cars is officially dead. People used to buy Toyota and VW for one core reason: superior engine technology. That century-old advantage is gone. Spending $30,000 on a traditional Western gas car today, you're not buying advanced tech. You're buying a century-old industrial relic. Second, long-distance range anxiety is permanently solved. A 2,000-kilometer tank range means most drivers only need to refuel 10 times a year. You can drive from China's northern border to its southern coast with just one gas stop. EVs fix city commuting problems. Chinese hybrid tech fixed long-distance travel once and for all. Third, this is a landmark breakout for Chinese high-end manufacturing. For decades, China only exported low-value goods. Clothes, shoes, toys. High-end engines, chips, and precision machinery were all Western monopolies. For the first time ever, China leads a core industrial field Western brands dominated for 100 years. From now on, global ICE rules will be written by China. A lot of people claim hybrids are just a temporary step and pure EVs are the only future. But here's the counterintuitive truth. Hybrids will dominate the global auto market for the next 10 to 20 years. EV charging infrastructure can't cover every region worldwide yet. Battery density still can't fix cold weather performance and ultra-long range limitations. Hybrids solve all these pain points perfectly. They deliver the smooth, quiet ride of an EV, plus the convenience and range of a gas car. Best of all, they cost far less to produce than pure EVs. Finally, let's talk about the bigger picture here. What even is a physical limit? Most people think limits are fixed truths written in textbooks, but in reality, most limits are just boundaries set by old industry authorities. Toyota declared 41% thermal efficiency the unbreakable ceiling for ICE engines. The entire global industry accepted that line as fact. But Chinese engineers refuse to play by those old rules. They didn't live in the shadow of century-old legacy systems. They use modern digital tools to redefine what's possible. True innovators don't respect old boundaries. They rewrite them with results. Data never lies, but most people only see the surface of what data shows. Casual viewers see a new Geely engine. I see the end of an old industrial era and the start of a new one. Now that China's supply chain has broken the West's century-old physical limits on combustion engines. Are legacy brands clinging to their century-old heritage, waiting for a graceful end? Or are they just avoiding a new era that's already here? If you had $30,000 to spend on a car, would you pay for outdated legacy prestige or vote for technology that just rewrote the rulebook? Drop your take in the comments below.